With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. Which theory can explain bonding in nickel tetracarbonyl, NiCO4? So we have four theories over here. Yes, MOT, CFT, VBT and Werner's. Well, MOT and VBT we have learned in chemical bonding. Yes, so MOT is molecular orbital theory. Yes, whereas VBT is the valence bond theory, wherein we had talked about hybridization. Yes, whereas CFT is your crystal field theory, and crystal field theory as well as your Werner's theory is a part of coordination compounds. Yeah, in case of CFT, in fact it's a mixture, coordination compounds and obviously the D block elements, where we have learned it to a larger extent. In this case now, what we would be doing is that we would be talking about nickel tetracarbonyl. Okay, NiCO4. Now basically nickel tetracarbonyl's bonding part, bonding in the sense I'm talking about the ligand approach and all. Yeah, so if we go to talk about the strong filled ligand carbonyl group, okay, which promotes internal pairing of electrons, okay, and hence gives rise to sp3 hybridization with a tetrahedral geometry, giving rise to a tetrahedral geometry of this particular structure. Since there is no presence of unpaired electrons, it's totally diamagnetic in nature. Now all these features have been given by the VBT theory. Yes, and of course in that case, if at all we were looking into as to how does the approach take place, or what kind of energy splitting of the orbitals would be taking place, definitely crystal field theory would help us a lot. But now what we are concerned with is the bonding part. Okay, now when we are talking about the bonding, it is literally about nickel, which is going to show us a tetrahedral nature. We would be interested in this particular bonding which is taking place. Now as you can see, the carbonyl groups share a triple bond between the carbon and oxygen of this ligand structure. Yes, so if this is the structure, I mean obviously this is the structure of carbonyl group, and the bonding with nickel of that of your carbon atom is a little weird one. I mean, it's not a simple sigma bond which you will be able to see. There involves a back bonding case in this particular structure. Okay, now what do I mean by back bonding? So back bonding is a concept, or other ways I would say it is observed or it is realized when we look at the energy of that particular molecule or of that particular complex, of that particular compound. So when we talk about back bonding, it is actually concerned with the metal and the ligand atom which is combining with each other. It is concerned with the orbitals which participate. Okay, so such kind of bonding takes place between the pi orbitals of the ligand and the metal. Okay, now there are different there are variations in this particular back bonding as such. So it's not just pi orbitals, but we do have the anti-bonding orbitals of ligand, anti-bonding orbitals of the ligand which also tend to participate. So that's your pi star orbitals. Now what is this all about? So let us have a look. Now in case of nickel tetracarbonyl, if we go to have a look into its bonding part, along with the orbitals, the lobes and all as we show, these would be the 4 lobes which are available. Okay, now there comes in a simple kind of an axial overlapping which takes place. And this is the ligand approach, obviously. So this is going to be a kind of a sigma bond which is formed. Okay. Now this sigma bond would be formed. Let me write it over here. This sigma bond would be formed when either the dz square or the dx square y square orbital, which is unoccupied, will be approached by the highest occupied molecular orbital, abbreviated as MO, of carbon. Okay. So there's a free electron pair over there. Yes. So it's also called as HOMO. Okay. HOMO, I'm sorry. That would be called as HOMO. That is highest occupied molecular orbital. And this is going to be your metal orbital, which is unoccupied. So that's your LUMO. Okay. So this is going to be approached by the carbon. Okay. It sets in its electrons and hence gives rise to a sigma bond. Now, a different case is going to arise when we are having the interaction of the occupied orbitals of our metal with the unoccupied orbitals of the ligand. Okay, what is it? I repeat again. Now would be the case wherein the lowest unoccupied molecular orbital of CO interacts with the pi, in fact the d pi orbital of the metal, okay, which is of course occupied. Are you getting my point? Yes. So the first case was wherein it was an unoccupied orbital of the metal and occupied orbital of the ligand. Whereas in this case, we'll be able to see that the lowest unoccupied molecular orbital of CO. Okay. Now, which is this lowest unoccupied molecular orbital? This we are talking about the pi star orbital, which is going to be seen. So these are the pi star orbitals, okay, which would be there, which would be empty, and they would be interacting with the filled up orbitals of the nickel atom. Yes, so this is what I mean by the back bonding case. Yes, definitely we are having orbitals also resting upon oxygen too. Yes, that is also there. But then specifically when we are talking about the interaction between the metal and the carbon of the carbonyl group, definitely these are the details which we get into. Yes, so the carbon monoxide orbital is the pi star 2p orbital. Yes, and that is going to be anti-bonding with the 2p character, since it is having the presence of 2p character more and more. Yeah, so in this case we can see the Lewis basic as well as the Lewis acidic nature of carbonyl group or the carbonyl ligand. Okay, so in the first case it was behaving as a Lewis base, whereas in the second case it is behaving as a Lewis acid. Okay, so this is what we talk about as a back bonding case. In fact, this particular theory comes from the molecular orbital theory part, that's MOT, and that is from your chemical bonding concept. Got the point? Okay, so in fact, if at all we want to understand the wholesome bonding of nickel tetracarbonyl, MOT would be the best one to explain. Yes, and hence we mark option number 1 as the correct answer. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.